All right, it says we're live. So
All right, I'm just opening up the quiz now.
what do you guys think of that game last night?
Oh my gosh,
Um,
that was worth skipping.
Yeah, it
yeah,
was.
Dude, I stayed up all the way through the end, man. I listened to it on the radio on my phone. Oh, dude, that you couldn't even hear the announcers anymore. As soon as that last out was thrown out, man, oh, it was on. All you hear is the crowd going nuts. There had to be more Cubs fans and Cleveland fans in Cleveland. It was sick, dude. It was awesome.
crazy.
Yeah.
All right, we ready to dive in?
Yep. You got it up?
Yep. Given
Yep.
a 90% confidence interval of 45, 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? So is it we are 90% confident? I can't remember exactly how the wording is.
Yeah, I think it is. I think that's how confident. There's only 10%
Yeah.
opposed to what you think. So we are 95. I'm sure it's going to be 90%.
So B.
Yeah, I think it's B.
Right? But I also think it's because the key word it's not 90. It's not the numbers. It's confident because it's 90. There's 90% confidence interval, and so I think that's the key word is the confident.
I
Okay.
think I just remember that because I got it wrong one time and I remember.
There you go.
Yeah. Okay. Researchers at the University of Mississippi wanted to determine whether the reaction time of males is different from that of females. The researchers randomly selected 20 females and 15 males to participate. The go stimulus. Okay. Decided to construct a confidence interval to determine if the difference of the mean is significant.
No, I feel like there's information missing.
I do too, but that doesn't reflect in the answers, I don't think.
No, that's the hard part.
I think it's D. Well, D seems like the most correct answer. Let's see. The distribution of the mean for each sample is normal since the researchers. Oh no, it's not D. Sorry.
No.
It would. So my guess would be A.
Yeah, I'm definitely going between A and B. Needs to check all data combined as normal. But even then, I think we don't have enough information for even B.
Yeah, it seems like the data is normal, but there's not enough.
Yeah,
Not enough to apply the. It's got to be at least 45 to apply the central limit theorem.
yeah, I'm going with A then.
Of the four types of confidence intervals listed below, which one is appropriate for this experiment?
Oh, goodness.
I think it's either B or C. They're not dependent samples, are they?
I don't think so.
Yeah, so I would go with C, but it might be B. No, they're looking for the difference, right? So I would go with C.
Using
You guys agree with that?
I don't know. I'm lost when it comes to that stuff, so I can't argue either way. So
Okay.
I'm tossed up between A and C.
Between A and C?
Yeah, mainly just because of the wording change. Is I'm trying to think if these would be. Do you see this as an independent or dependent?
I see it as independent since the two numbers randomly select 20 females and 15 males to participate. They wanted to see how the males differed from the females, but I don't see how those two would be dependent on one another.
I think that they're dependent. Well, yeah, they're dependent on each other because you have no test unless you have both of them. Like basically, you got to have females to compare against males and males to compare against females.
No, but a dependent sample would be um, something like, um, gosh, what's an example of that? I can't think of one right now. I, from what I understand, it would be a number A would or the second sample would depend on the first. Meaning if you didn't measure the first, the second would be different. But in this case, if you just measured males or just measured females, they would be the same number. It wouldn't.
You would still come to some kind of conclusion.
Yeah, I can't.
that makes sense. I mean, you're gonna get the same number.
Whether you only have the 15 males versus the 20 females.
Yeah.
Yeah. Let's see if I'm gonna see if it says anything about that in the reading.
Holy crap, that is 32 questions.
Yeah. So the reading only gives us the questions.
Correct.
Oh,
Yeah,
let's see that.
we'd have to go back to. Yeah.
So why did we click on? Okay.
Let's just roll with one of them and let's see what happens when we submit it.
Here's what it says in lesson 13 recap. In contrast to dependent samples, Two samples are independent if knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2. With independent samples, there is no pairing between the groups. So you might be right. I'm not 100% sure about that. The key characteristic of dependent samples or matched pairs is knowing which subjects will be in group 1 determines which subjects will be in group 2. I'm cool with rolling with dependent. That's fine. So let's go with A on that one.
Sounds good.
Okay.
Number 5 then.
Yep.
Researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3,400 and 4,100. Which of the following would produce a confidence interval with a smaller margin of error than the 95% confidence interval? I would say it'd have to be 99%.
Yes.
That's small.
Because you're even
Yeah,
close.
You're going.
No. Which would produce a confidence with a smaller margin of error? Wouldn't the margin of error grow if it was 99%?
Yes, it would.
So I think it would be D, right? Or would that also shrink it?
In the balance.
No, whichever way you. I'm trying to remember.
So they're saying they're 95% confident that customers will be between 3,400 and 4,100.
Right.
So to say that they're 99% confident, the numbers would have to grow either way. You know what I mean?
To help cover more of a spread, I can see that. Yeah, then it's got to be one of these answers because 90% is not available.
It could be one of the A or D. Obtaining more samples, I think, would decrease the margin of error, and obtaining less samples would increase the margin of error. So I think it's A. Wait, with a smaller. So it would be D. Sorry.
Yeah. I was gonna say I think D is what you were trying to go at.
Yeah. So it would be D because if they collect more samples, then the margin of error shrinks.
Right. And I think that's one of those tricky questions where it's like C and D technically are correct answers, but D is probably the more correct, if that makes sense.
Yeah. Well, if it's not D, well, no, it's probably C. So.
Right.
Okay. You guys remember how to do this? I don't.
I know it's 1.96.
Yeah.
Yeah, I've got it on my spreadsheet.
I think that's in lesson 10, right? So if you go to lesson 10 recap, is that the... Do you guys see where the recaps are?
I don't.
In the lesson summaries,
Uh-huh.
hit show summaries. And then it'll give you all the recaps.
Show summaries.
It's a little there's a little link on the right-hand side of the page there.
You went to lesson 10.
No, I'm talking about this week's reading, lesson 15.
Oh, okay.
So under section 2, you just hit show summaries, and then it'll give brief summaries of each lesson, which is kind of nice.
It is nice.
So it shows you a confidence interval. I think it shows you the confidence interval equation there.
I come up with 1.96.
I think
1.96 is also the equivalent of z-score for the 95%, but that's literally what I'm getting. So the thing is that you have the standard deviation, which is 2. Then you also have to figure out what the square root of the sample size is, which is 4, which is going to be 2. So then you have 1.96, multiply it by 2, then divide it by 2, and that's going to give you your confidence level. So, of course, basically you're just saying 1.96 times 2, and now take that 2 back away, and you got 1.96 again.
So basically 1.96 times 1.
Pretty much, yeah. Yeah, because the 2s are going to cancel each other out.
Okay, yeah, that looks...
It makes it easy, too, because if the mean's 1,000, you just have to, the lower is going to be take away 1.96, and then the upper is going to be adding the 1.96.
Right. Perfect. Yeah, that looks good to me. 0.96. Input the lower bound, so we're going to go 1,000 minus 1.96 is what you're saying?
Right, exactly. So I have a 998.04.
Okay, and then the upper bound, you have the 1,001.96.
Exactly.
Okay.
Is it double because it's a 95% confidence interval?
It doubles, but then you also have to then divide it by the square root of the sample size, which happens to also be 2.
No, I'm talking about when you're inputting the lower bounds.
No. So your confidence level is going to be, so like for example, this answer happens to just be 1.96. So that means it's going to swing both ways. You are 95% confident that if the mean is 1,000, it's going to somehow swing 1.96 one way and 1.96 the other way. I'm 95% confident that is going to be the range on finding the mean.
Okay.
Yeah.
Does that make sense?
Yep.
Okay, question 9. To assess the accuracy of laboratory scales, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times. Mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01. How large should n be so that a 95% confident interval for mean has a margin of error 0.001? So we just solve for mean, right? Is that what they're asking us to do?
Yeah.
Okay. So we just take the margin of error calculation, stick all the numbers in there except for we don't need the mean, but
Yeah, it sounds like we've got to find the sample size.
Yeah.
okay. So that's fine. We just plug in. So the calculation I have is m equals z times what is that, standard deviation over square root of n. So we just don't have n.
Correct.
Okay.
Yeah, and there's a formula for that. I remember that. It was a question about light bulbs, how many they needed to test.
I gotta go grab scratch paper.
So then what are we trying to do with this? What was the equation he just read off?
It is m equals z times the standard deviation divided by the square root of n.
Where m is going to be.
Hey, there, right below that. There's the formula to solve for n.
Oh, really?
Formula. So n is equal to z times the standard deviation divided by the mean squared.
Okay, perfect.
So say that again. N equals?
Z times the standard deviation divided by m, and then you square your answer.
So it's going to be 1.96 times
Our standard deviation.
which is 0.01.
Right.
Divided by
m, which is 0.0001.
3 zeros.
Yep. And then you square all that. Do you square it last? Yeah, I think that's what you do.
Yep.
Okay.
It's not parentheses or anything, right? So we don't square it first.
No, you do everything inside the parentheses and then square it.
Square it, yep.
Divided by point. Okay.
I got a big number.
I did too.
Yep. 30. I got 38,416.
That's what I got.
But that's what you're going to have when you have all those decimals and then you're dividing it. It then turns it into a multiplication.
16.
38,416.
Okay, yeah, that sounds better.
Right, because when you're dividing it and you got a 0.0196, but you're trying to get what is that? 10 hundreds, thousands, millions, 10 thousands. When you got 1/10,000th, trying to how many times does that fit in to 1.0 or 0.0196? That's a lot. So yeah, we're gonna have a big number there.
Yeah. Well, that sounds good to me. I don't.
38,416.
All right.
Yeah, that's what I got.
All right, so let's see. The mean area mu or whatever of the several thousand apartments in a new development is advertised to be 1,250 square feet. The tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are.
So
of course it's going to be
Equal to
and
12.
C so far. The first half of it's correct, or A, B, and D. It's going to be 1,250, but then we want it to be.
they think that the alternative, they're going to say the mean is less than.
Right, so it's going to be D. Or no, wait. Yeah. No. Yeah, it's going to be
Yeah.
D.
D.
1,250 is going to be greater than the alternative.
Yep.
All right. 11. In a statistical test for hypotheses, we say we reject the null hypothesis with the level of significance A if
0.05.
If the p-value is, let's see, we reject the null only if the p-value is less than A. 0.05 is what they've usually used, but it could
Yeah,
be
both
point
are-
0.1. It could be 0.1 representing 90% confidence, or it could be a 0.01 representing 99% confidence.
It's so we reject the null if p-value is less than
Right.
A?
Yep.
Okay.
If it's less than A. If P is below, then you reject the null.
And if you don't know P, then you assume 0.5 or 0.05.
They should tell you in the problem what it actually is. That way you know how to judge it.
Okay.
Yeah,
And they'll either phrase it as 95%, which means 0.05, or they'll phrase it as 0.05 representing 95%. Whatever percentage they put in, it's basically out of 100. So out of one whole number, is it going to be 95 or is it going to be 5? Does that make sense? Like that's the relationship. That's how you figure out what the A would actually equal.
no, they should give you the level of significance. It can be anything though.
Yep.
Right.
Okay. So B. Well, says a group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from anonymous random sample size of 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer this question?
I think they can.
Yeah, I would think it's C.
Mm-hmm.
I mean, because we had some where we did the ANOVA the other night, and it was some of them only had like 13 samples. So I don't think it's necessarily the full size of it. It's just a matter of, you have several different ones that you can do at one time.
Yeah, I would say it's C as well.
Alrighty.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. She tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at a 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has... Oh, I don't remember
I think that's a type 1 error.
Yeah, I don't remember the difference between them, but I know it's one of the errors.
Type 1 is when you reject the null but didn't have. And then type 2 is the opposite.
Type 2 is what?
Type 2 is when, let's see, maybe I don't remember. I think it's type 1 where you reject.
So a type 1 error is committed when we reject a null hypothesis that is in reality true.
I think so.
Right.
I'm reading that.
Yeah. Yeah.
A type 2 error is committed when we fail to reject a null hypothesis that is in reality not true.
So
Yeah,
type 1.
Yeah.
Yeah, it's a type 1. Yep. Oh.
Okay, if the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability committing a type 2 error? It increases.
Right. Yeah, so I put A.
Yep.
They have the opposite effect on each other.
Yes.
C15. The nicotine content in cigarettes of a certain brand is normally distributed. with mean in milligrams, mu, and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
Oh man, now I have to actually do work.
So no, because I mean it's less than 0.05. It's 0.03 from the mean, or point.
It doesn't matter. We have to find a p-value. So to do that, how do we find a p-value? I think do we find t?
I watched part of his screencast that went over P's and T values, when to use which ones, but I do not remember.
Okay, let's see here. So we have the sample mean, we have the population mean.
Right. We have the sample size.
100 cigarettes.
So it's obviously either C or D.
Right.
I think it's C.
Failed to reject.
Mm-hmm.
I'll go with that.
So we're seeing that
Failed to reject.
it is higher than the level of significance, or lower than the level of significance.
Lower, yeah.
You would like to look at the mean number of hours worked for wages per week by male students and female students. You'd like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Is it a paired sample t-test, or is it an independent sample t-test?
I think it's independent because they don't have to be related to each other.
Okay.
So, like in other words, the amount and the wages have nothing to do with the amount of the hours.
Yeah.
It's just they just need hours. They just need wages.
That makes sense.
Well, if we get it wrong, I think, well, no, that's the other one.
Well, good thing is we're already halfway done. We'll see how the rest of this goes. Knock on wood.
Right.
Number 17, an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? That's going to be dependent
Yeah, I believe so.
because they have to have, no pun intended, due to the fact they're brothers and sisters, but they have a relationship to each other. There needs to be something that links them together that she can't use any other sample.
Yeah,
Would
so I
be-
think it would be D, right?
Yeah.
The sister is a D, or I only read just dependent sampling. B, the sister's academic achievement depends on some degree.
Yeah, it's not
No.
some degree. It's
No, the sister in your study. Yeah, D is definitely the better one.
Okay. Number 18. Use the following information to answer the next 4 questions. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded and dissolved. Okay, that Excel spreadsheet. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field.
okay.
He's trying to
I'm not very.
confidence interval for the mean dissolved.
Okay, I got that open up. Of the 4 types of confident intervals listed below, which one is appropriate for the situation?
Uh, don't think it's B.
I think it's C. Wouldn't it be C? Can't you find, or maybe you don't? No, you don't know. We don't know what the standard deviation is.
Right. Well, I mean, if we go through it, we do, but I don't know how it separates the different soils when it's all in one column.
The reason we don't know we know what the sample standard deviation is, but we don't know what the actual standard deviation is.
Yeah.
So I would say A because we only have one. Unless I'm missing something, we only have one category of samples, so it wouldn't be dependent or independent samples. So we can't do the difference of means, can we?
I don't think so. I think I like A.
All right, let's go with A. So I think we can open up that one worksheet that we got.
Yeah, I think we'll have to get the mean, the sample size.
Yep.
Can we use the quantitative inference procedures?
Yeah, we should be able to.
And I think it would just be the one sample t-test, right?
Yeah.
Okay, let's try it.
I'm still trying to open Excel.
No worries. Okay, I've got it inputted. So I got 2.025.
And you did it on a one sample t-test?
Yeah.
And I got 1.9.
For the margin of error?
Yeah.
What did you get for the lower bound and the upper bound?
Upper I got 21.9. Lower I got 18.104.
You got 8.104 and 21.
I got 21.9 and then 18.104.
Those numbers don't add up though. If your margin of error is 1.9, there's no way you can have that large of an
Oh
difference.
no, you're right. I did my calculation all messed up.
What was your standard error, the mean?
What was what?
What did you have for your standard error?
No, I'm not talking about standard error. I'm talking about margin of error.
13.
Margin of error is 2.025.
Are you on the quantitative procedure or statistics?
Quantitative inference procedures.
On a one sample t-test.
Yeah. It's not going to give you the margin of error. You have to figure that one out. It'll just give you the confidence intervals, and then I just figure out. I just subtract the lower bound from the upper bound, and then divide by 2 to find the margin of error.
So for your confidence intervals, did you have 15.218 and 11.618? 11.1.
15 I have 15.217. And then 11.168.
2.025. So for the lower bound, On the next question,
You on 22?
no, on 20,
11.168.
11.168, and it's 15.218.
And Nate, you said you got 15.217.
Yeah, I got 217.
If you move that, if you make the column wider, does it have additional numbers that you can round up to 8? Maybe that's why he's getting 8.
No, mine's 21738.
Oh, gotcha.
Yeah. So I'm not quite sure how we got different answers though.
How far did you take out your standard deviation?
Oh, maybe that's why. Well, even if I take it out 6 or 7 decimals, I'm still getting the same. I'm still getting the same on the confidence intervals.
So I put them all the way in.
For the
Yeah,
margin of
Stan,
error, for the margin of
I've
error, you
got
got
a mean.
2.024.
5 is what I got.
I'm sorry,
And
what's
you
that?
know what? I'm gonna check.
I got 2.025.
Oh, yes, if I rounded, I would. Okay.
I'm not sure if these are the right numbers or not, to be honest. I'm not very confident in them. Oh
No?
well.
Yeah, I try to just figure it out a different way with the equations I already had in, and I came up with slightly, like very close, but still slightly different numbers than you guys did.
Oh really?
Yeah, I still came out, so instead of the 2.025, I still came up with the 1.9, but I put the sample size in where my mean was supposed to go, and so that changed it from the upper I had is 15.089, and then my lower is 11.297.
Yeah, that is close.
So I do not know. But what we can do is that you guys can at least put in like Nate, you can put 217. Alex, you can put in 218. I can put the numbers I get, and we can see just where we go.
Yeah, let's do that.
So let me put my numbers back in real quick.
All right, random. Moving on, 22.
Yep.
Random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded and used Hummers. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Okay, that shouldn't be too hard.
So for 22,
Just a lot of them.
yeah,
Holy cow.
Yo.
So would it be a paired sample or a T sample or a two? It would be a paired sample, right? Because we know the difference.
correct.
Right.
So Los Angeles is Group 1 and New York is Group 2.
We're doing price, right?
Yes.
And you put New York as group 2?
Yeah, that's what it says to do.
Okay.
I like how they throw all this other information in here like it's important.
Yeah. Actually, I don't think it would be paired anymore because there's going to be a different number. So I think it's going to be 2 sample t plus.
Why is that?
Because there's going to be a different number of cars in Los Angeles than there is in New York. There's no way we can do paired.
Okay.
Yeah, they're way different. They're just so different. There's 109 in Los Angeles, and then there's, or maybe, 108 in Los Angeles and 63 in New York.
Yeah, that's what I just noticed as well. I just got rid of all the extra data and just copy and pasted all of Los Angeles next to New York, and it's a significant difference.
Yeah.
There's 63 in New York.
Yep.
So for the standard deviation in New York, did you get 75, 7,521?
I'm not there yet. Are you asking about the standard deviation in New York?
Yeah, I was just going to compare our answers for it.
So I got 7521.461.
For the,
So you got,
yeah, I rounded it to 0.5. But, so for the mean, I got 40,144.
yep.
For Los Angeles, 11,803.
Yep.
Standard deviation of 42,641.
Well, those are switched. I got 42,461 for the mean in Los Angeles.
Yeah, I got
And
42,
Yeah,
641.
I switched them.
Okay, so what are they asking us to do? For the 4 types of
That's what I had to do too.
well, which of the I think we do independent samples. So C for number 22.
Yeah, I don't see.
Yeah, because we couldn't use the paired test.
No.
I mean, yeah, I mean, the only thing that they could compare to each other is the fact that, like, the criteria would have to be Los Angeles and New York, and they're Hummers, but that's not dependent. That's the only thing. There's nothing to compare it to be dependent.
Yeah. Okay, which of the following is the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and New York? Input your answers for the lower bound and upper bound. I got a negative lower bound. Did you guys get a negative lower bound?
I'm trying to figure out how to even get that.
23.
I got negative 423.238.
Yep. Upper bound of 5417.336.
Yeah.
What was your upper?
5417.336.
5417.336. Okay. And you said your lower was negative 423.328.
238.
238, yeah.
So 423.238.
All right. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups selected at random for the 3 groups. A control with no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group at 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats expressed in whatever was measured, the data are recorded in this Excel. Researchers would like to determine if the mean levels of bone density are different between the 3 groups of rats listed above. So we can't use one sample, can we? No.
No. I don't think we can use paired samples either, can we?
Don't think so.
I don't know.
I think we could ANOVA though.
Use the ANOVA.
Yeah, that's when they immediately caught my attention.
This is like the soccer cleats one, it looks like.
Yeah, where it had the 6 samples and one was just socks.
Yeah. So I think we do use the ANOVA.
These are all the same sample size this time.
Because we can't use 3 variables in the paired test, can we?
I don't know. The only way to do that is to open it up and see what it says.
Paired test, variable 1, variable 2. We have 3 variables.
You could probably do them all independent of each other.
Okay. So which one are you guys? What are you guys thinking?
I think it's the ANOVA.
Yeah, I do too.
Okay. So I input this into the ANOVA.
Come on, Anova. What up?
The only thing is, I don't think ANOVA gives us the test statistic.
Do any of them give us a test?
The one sample T test does for the means. The very first one. The pair test does.
Paired test does as well. All of them do except the ANOVA. So maybe it's not ANOVA, but I don't know which one to go with.
All right, which is the correct hypothesis test?
Is there a way to calculate it? I'm wondering why it says calculate the t-test, and on 27 it says give the p-value.
Right. So to equal T, let me see here. Give me a second. Looking at my notes. So a test statistic is the sigma. Crap. 45. So you take the mean divided by the mean or subtract the mean population. So you have the mean, you subtract the mean population from it. Then you get your standard or your sample standard deviation divided by the square root of the sample size.
I don't know if we have a mean of the population.
I don't know if we do either. Let me see here.
So we like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. I think that's an ANOVA.
I just don't see it being anything else because I don't see anything else where you can put 3 or a third column in.
Exactly.
And everything is specific as far as the.
I don't know. I just put 0, I guess.
Come on.
Mm.
You think it's 0?
Oh, I don't know. I was just going to put 0 if I couldn't find it. Sometimes the answer is 0 on those kind of questions.
Right.
Yeah.
So the p-value is 0.002.
Yeah. Conclusion of the test. These are the ones that always get us. Insufficient. So the p-value is less than the level of significance, which means we fail to reject the null.
Yes.
So we fail to reject the null if it's less than the level of significance.
If it's less than level, if it's low, so if it's below the level of significance, you reject the null. If it's a low, reject the null.
Okay. So I think the answer on this one is there is insufficient evidence. There is insufficient evidence to conclude that the mean bone density of all three groups is about the same.
Right.
See?
That's what I'm thinking.
C.
That's great. It gives us 5 different answers to choose from.
I know.
That's awesome.
God. They don't make it easy on us, that's for sure.
I'm sick of downloading Excel sheets. Why can't they just put them all in one?
Well, sir, that would be easy.
Yeah, they can't make it easy on us. All right, home stretch.
So what did you guys end up putting for the T statistic? 0?
Yeah, because I don't know how to calculate that.
He's having an office hour tomorrow during the middle of the day if you guys don't have a job.
Right. Yeah, I don't already work 50 to 60 hours a week.
All right. Pressures of supply and demand act directly on the prices for an airline ticket. Seats are available. The plane begin to fill. Airlines raise their prices. Seats on a flight do not do well. Airline may discount tickets or even cancel the flight. The study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance. The scheduled flight compared with a ticket purchased only 14 days in advance. Used this sheet before, haven't
Paired sample.
we? Yeah. So, a hypothesis test to determine if there's a difference in the mean cost tickets are purchased 14 days in advance compared to 90 days in advance. Use a 90% confidence interval.
Said 90%?
Yeah, well, it's 0.1.
Right. So it'd be 90%. Yeah.
And a paired sample is not an option for the correct answer.
Really? What about a dependent?
A dependent samples test, yes.
Yeah, that's the one. It's the same thing, paired and dependent. Same thing, I believe.
So that's where you guys are throwing the numbers.
Yeah, I'm throwing it in paired.
And of course, I closed the wrong Excel spreadsheet. I need to reopen quantitative.
Um,
Go me.
Really.
Come on, guy. Do this.
Does it say? Does it say which one to use first? And I guess it doesn't matter here.
What's that?
It doesn't matter which one goes in which column.
Yeah, it does. 14 days is going to go in column 1. 90 days is going to go in column 2.
Correct. And you guys got to watch too. There's some of them with words in them.
Where do you?
There's what?
Some of the cells have words, so you can't just drag down and copy.
Oh, really?
Nope. Maybe I'm making stuff up. There's a couple of them with gaps, though.
There are a couple of them with gaps. Yes.
Crap. Yep.
And I think you do need to make sure that there's one with gaps in both. So I think you need to delete that one. You need to delete that row because it's going to come up with a 0 and it's going to mess up the average and stuff. We did this in the homework last week or something.
Yeah, I remember.
You guys remember?
So you got to take out the ones with the gaps.
This one there's 2 gaps.
Only
Yeah, there's
the
two
one where there's 2 gaps.
So 58.
So there should be, or maybe it just does it for you. Yeah, the ones
Yeah,
with
it should
gaps.
just do it for you. The white cells, it should just do it for you.
Okay, so the ones with gaps just aren't registering, right?
It does change the standard mean of the standard error of the mean. I didn't notice anything else change. Maybe they did, but for sure the t-score stayed the same. The statistics stayed the same.
Okay.
But when I took out the gaps, it's the standard error of the mean.
Oh, okay. Well, I'm not worried about that number.
Right.
So this one doesn't have a t-score. A test statistic either, does it?
Yeah, it does.
Of what?
Where's it at?
18.403.
The t-score?
Yeah, where do you see that at?
Under T,
You got how much?
18.403.
I got a .837.
Really?
I don't have a t-score.
Well, hold on. Maybe I'm not doing the right test though either.
You guys are on paired sample t-test, right?
Negative. I'm in 2-sample t-test.
Oh.
I don't know.
Oh, my goodness.
So at the bottom, what does yours say, Alex? It should say T, DF, p-value, and confidence interval.
Yeah, I'm in the wrong spot. Give me just a minute here. I screwed up.
All right, so let's change this information. Put it in the paired sample t-test. And you got a t-value of what?
18.403. So make sure for the mean and the standard deviation, you're calculating it on the differences column. And then make sure to change the confidence interval to 0.9.
Okay, so the mean.
Sample size is 88, right?
I have 87. You're looking at differences, not the variables.
Okay.
You should be.
Yeah, I'm not getting a t-score. I'm at 1.685.
You have 1.8?
1.68. What are we
I have,
doing?
I have a 1.53 still.
What did you do? You put not equal to?
It doesn't change the t-score anyway.
Yeah, that t-score is wrong. I already submitted it.
What other ones we get wrong?
Not too many. Let's see. I got the last 3 wrong.
So
And
30,
then,
32. Okay.
and then just a couple other multiple choice. And then that p-value one. Let's see.
The answer's not 0?
No. So,
That's crap.
number 3 was wrong. Which I don't know what that answer would be.
I don't know. So 3 was wrong. What else?
I'm gonna reopen my test here.
So is it just those 5 that were wrong then?
No. 3 and 4 were wrong. And then
And that one about p-value.
number 15 was wrong. So it must have been D on that one.
Let's just walk through it. 3 was wrong. We picked A. So would it be C?
I don't know.
I'll try C.
Yeah, try C. That seems to be the other one that would be.
What's that for 15?
No, for 3.
Oh, for 3?
Number 3.
Well, 15, since we didn't.
No,
I
number 4 is the next one we need to address.
Yeah. I'm sorry, what did you guys choose for 3? C?
C.
So 4, we picked A, right?
Yeah. Of the 4 types of confidence intervals listed below, which one is appropriate? It's appropriate for this experiment.
Let's try the independent samples then.
Yep, that's what I would do.
So change it to C, yeah?
Okay, and then let me see which the next one we got wrong was. We got 5 correct, which was D. We got 6 correct, which was 1.96. We got 7 correct, which is 998.04. We got 8 correct, which was 1001.96. We got 9 correct, which was 38,416. I think we got 10 was correct, and we picked D. And 11 was correct, and we picked B. 12 was correct, and we picked C. 13 was correct. 14 was correct. And then 15 was incorrect.
I think it's
So,
D.
I think it's D because DHO, that would be the null.
yeah,
And just by basing off of the information that we have, looks like a 0.03 would be the difference, which is below. So if it's low, you reject the null.
yeah.
Okay.
16 and 17 were both correct. 18 was correct. We picked A. 19 was probably... Oh, 19 was correct. So 19 is 2.025.
2.025. Got it.
Yep. And then 20 is 11.168.
11.168.
Yep.
Okay.
And then 21 is 15.217.
All right.
Okay, and then 22 was correct. We put C. 23 and 24 were correct. 25 was correct. 26 was incorrect. Didn't even put an answer. 27 was correct.
0.002.
Yeah.
Cool.
28 was incorrect.
28 was wrong. Okay.
So probably B would be my next guess.
Oh yeah, I missed that one. There's insufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density. Yeah, that's the one. That's how they word it. Good call. And 29 is correct. Dependent sample tests. And then the last 4, or how many is that? The last 3 are
Yeah,
all incorrect.
So we need to go back to 15 and change the T statistic and then fix 30, 31, 32.
Yeah.
So for 30, for the T statistic, I got 1.685.
1.685.
Yeah,
Okay.
I'll try. What type of that's is it not equal to, or is it greater than or less than?
It's not going to matter because you could go up there and change those boxes. It doesn't change my T score at all.
It changes the p-value though for the next one.
It does.
So let's see which one it would be.
Because we're comparing the two flights.
It's going to be, it should be in the wording here.
Right. It's going to either be greater than, less than, or not equal to.
So it's just saying if there is a difference in mean cost. So I think it's just not equal to.
Right.
It's not saying one is greater than the other.
Yeah, that's.
I think that's what we're supposed to do. So what do you guys get for the p-value there?
For the p-value there, I got. Hold on a second. I got 0.096.
See, and I'm getting different numbers.
Yeah, I'll submit mine. We'll see if I'm right. Now you can submit yours. What did
What
you
do we do?
32?
Huh?
Nate, on 32, what did you put that was wrong?
Oh, I put D.
Okay. So I'll put A.
Yeah, good call. Try A on that one.
Then we got to go back to 15 and work on that one too, right?
Missed 3. So 32 is wrong.
A is wrong on 32.
Yeah.
Okay.
8 is wrong. And 26 is wrong.
8 shouldn't be wrong.
No, it should be 1001.96.
Yeah. I got 8 right.
8? No, I'm 32 is wrong.
Uh-huh.
Uh huh.
28 was wrong.
Okay.
Oh, I got you. Maybe that's what I heard wrong. Okay.
And 26 was wrong.
Those are the only 3?
Yeah.
So 28 is not B or D.
I'm surprised 28 was wrong. I thought.
Did you say we got 28 wrong again?
Yeah.
So I would say my last guess would be D.
So when you did it the first time, Nate, you chose A.
No, C.
We chose C the first time. We chose B the second time.
So now it's got to be D.
D would be my last guess
For which one?
for 28.
Yeah.
Okay, and then we got the last three wrong again.
No,
Oh, just the last one. We got 20. What do you say? 26, 28, and 32.
Yeah.
Nice. Okay.
We don't know 26. I don't know how to do that one.
So 32.
I think A.
We've guessed D and A, so it's either B or C. So should we guess B? It looks like we have sufficient evidence.
So if it looks like that, then the answer is going to be B.
Yeah.
So did you guys get the answers for the other ones that I put down for 31, 30, and 29? Or 30 and 31?
I got 1.685 and then 0.096.
Yep.
So hold on. So what is that again? 1.685.
Yep.
The T statistic.
Yeah, that was the test statistic was 1.685.
And your p-value was 0.0 what?
0.096.
0.96. Okay, that's good to know.
Yeah, I submitted it again and I only missed 26.
Did you go back and do it or no?
No, I just guessed.
What'd you put for 32?
32, I put B.
B, yeah. Yeah, I'm not gonna go back through mine. I got a 90. They're not weighted enough to go back through and change those two answers.
Right.
So
Do you need any other answers?
No, I'm good.
All right, cool.
All right. Good luck on the test, guys.
Yeah.
You man. You guys have a good weekend, and too bad baseball's over now.
All
Study
right.
hard.
Talk to you guys later.
Kidding.
All right, we'll see ya.
All right, bye.